Okay, factorial notation is introduced in 9.1, but then they don't do a lot with it. But these types of problems, especially problems like the back without the numbers, show up on assessments like SAT and the CLEP test and things like that. So we want to make sure we supplement this and make sure we can simplify some of these. Okay. All right. So remember the definition of factorial. Actually, let me find that in the 9.1 notes as a starting point. Definition of factorial notation. When you see that, it means this. We start by multiplying by whatever n is, and then we subtract 1 from it until we get down to 1. So here's an example of that. 5 factorial means that number n, 5 times 1 less that, 4 times 2 less that. Okay, now I'm down to 3, and so on. Keep subtracting 1 until we get to 1. Okay? All right, so this first one says, write each expression as a single factorial. You're just kind of practicing the definition. So this is just going to be, simply put, 8 factorial. That's how we express that as a single factorial. Okay. I'm going to do some of these for you, then you got to kind of fill it in as the OTI. Let me jump down to C. Okay. Now this one is in terms of variables, but this is just kind of the definition. When I looked at the definition here and was using 5, right, we just kept going down. 5 minus 1, 5 minus 2, and so on. So this is starting at n times n minus 1. So if this is 100, this means 99, this means 98, and so on. So this just means n factorial. It's the definition of n factorial. That's how I can express it, as a single factorial. Okay. All right, let's take a look at number 2. Let's go ahead and read those directions. Okay, so include at least 2 beginning and at least 2 ending terms. They're giving you the ending terms. That's how factorial works, right? This was the ending term. All right, so if I do B and I start with the first 2 terms, I'm going to do this. 1 times 2 times, and they're trying to saying you can do dot, dot, dot. We don't have to do this forever. They're saying start it and finish it. And then we pick back up at the last 2 terms, which would be 44 times 45. Okay, makes sense? Kind of a short way instead of writing out all 45 numbers. 2 beginning and at least 2 ending terms, or more if you prefer. All right, let's take a look at this variable one. N plus 1 factorial. Well, remember how you get this next term. It's kind of up to you how you want to do this. If you want to start with the smaller numbers first, let's go ahead and do that to begin. So 1 times 2 times dot, dot, dot. And n plus 1 factorial needs to be my last term. So I'll leave a little space and put n plus 1 factorial here. Okay. So I'm setting this up just like B. Here's the trick. How did I go from 45 to 44? It's minus 1. So to get this next term, I just need to subtract 1 from n plus 1. So just n. Yeah, so here's what I mean by that. N plus 1, and we got to take that and just subtract 1 from it. No different than taking 45 and subtracting 1 from it to get the next term. It was 44. Here, now I just get rid of those like terms, and it's going to be n. Okay? So it'll be n plus 1 factorial times n. Yeah, I guess for dot n or just parentheses n is fine, I guess. And that's it. And then always check your rules with the variables. I mean, let's just say it's n is equals 100. Does this make sense then? 100 plus 1 is 101, and then this would be 100. Sure, it's going down in value. So always check that. So there's the answer to C. Okay. All right, let's take a look at some of these down here. 3. Let's start with the first one. Simplify these expressions. Now, sure, our calculator give us our answer right away. What we're trying to do with number 3, though, is get ready for problems like this that show up on the SAT and the CLEP test. All right, so this shouldn't just be calculator work. Let's use our brain. Okay, 6 factorial, the bigger number contains the other factorial. What in the heck are you talking about? This is what I mean, right? 6 factorial by definition means 6 times 5 all the way down to 1, right? But I can stop right here. I can do 6 times 5. Instead of doing 5 all the way to 1, I could just do 5 factorial. This is 5 factorial. I can divide these out now. So what am I left with on top? 1 over 6. Now here's the long explanation. Okay, your brain just exploded. You don't understand what just happened. Look, what if I expand these? You can just watch this or include it if you want to. 5 factorial technically means this, right? 6 factorial technically means this. Okay, we're all set with that, right? This is how the problem started. Okay, what's in common? This, the 5 factorial and the 5 factorial. That's why I didn't waste my time writing it out. We can stop there, divide it, and jump to 1/6, okay? But I'm not going to do this every time. I want you to start using these factorials. Why don't you pause for a moment and try B. Okay, here's your feedback on B. So the bigger number 7, obviously. And then once I start breaking it down, I can throw the brakes on at 5 factorial because now these are equal. They're going to divide out, and I'm left with just the product of 7 times 6. So 42 over 1, or just simply put 42. I'll show you a couple more from this group. C, this one's a little bit different. We're squaring it, so just write it like this. If you square a number, it simply means 3 factorial times 3 factorial, all over 9. Now, the bottom's not 9 factorial, so this one, you can probably just use your calculator or just your brain, right? This just means 3 times 2 times 1, so that's 6, and this is 6, okay? So 6 times 6 gives me 36 over 9, which simplifies to 4. I mean, there's another way you could do this. I have this key here that does it this way, but these numbers, just a little bit different of a problem. I guess I could expand them to 3 factorials and then cross those out. 3 times 3 is 9. Cross those out to make it a little bit easier, but this is fine too, okay? All right, let me take you through F and J, and then should be enough and go to the next page. When you have parentheses with a factorial outside, we actually saw that on the first day of 9-1. I think they had something like that, like an n minus 1 factorial. You need to do that first. So 4 minus 1 is 3. Now I'm going to apply the factorial outside of parentheses, and now this problem is just like A and B. Okay, so I'll stop there. Let's take a look at one more here. Let's look at J. All right, now this says pieces, so before I try to multiply those together, let's try to fix what I can here. Let's just wait on the 3 factorial. So what I mean by that is we know 39 factorial contains 38 factorial. I can write it like this. And now I have the 38 factorial that I can reduce out. Okay, divide it out. Now I'm just left with 3 factorial, which is 6. We just did that math. Over 39. And then just reduce the fraction. Let's see what 3 goes into both of those. So divide that by 3, I get 2 and 13. So 2/13. Okay. Okay, let's start with D. Remember, to get the next term in a factorial, you subtract 1. That's what we practiced on this previous sheet, subtracting 1. So this is the bigger number, right? If I take a number like 100, add 5 to it, add 1, this is the bigger number. So this one contains this one. Okay, same strategy I was just talking about with 39 and 38. 39 contained 38. So let's start expanding this. So if I want to start expanding this, I'm going to write this as n plus 5 times, what would be the next number less than that? N plus 4. Oops, assume the wrong way. There we go. So the next number lower is n plus 4, and then let's just keep going. Times n plus 3 times n plus 2. Oh, I'm almost to the point of containing the bottom one, right? Times n plus 1, and let's stop there and write that as n plus 1 factorial. Okay, so these will divide out. And now I'm left with this. I guess it'd be okay if you just circled that. But you don't have to expand this and multiply back out. They're just going to expect that as the answer. So cleaning it up, here's the final answer. All right. E and G get pretty tough. They're challenge problems. It's kind of up to you if you want, but with everything we've done, I'm going to kind of stop there, and maybe we'll come back together at the end of the hour with some of the tougher ones. E and G, you can make those two kind of optional. If you like the challenge, do it. I'll have the key ready for you. But everything else on this worksheet is going to be part of your assignment. So finish everything else that we haven't done. Along with, I'm going to give you about 6 problems from Thursday and Friday to make sure we are not forgetting that either, and into our first 9192 quiz, okay? All right. This one's a little bit tougher. Here you go. And factorial squared, gone. So now we're left with this, right? Which one is the bigger number? If this is 100, this is 99. So this is the bigger number. This one contains that one. So start breaking it down on the bottom. How can I just take the definition of factorial? What does it mean? I start with n, I go down to n minus 1, n minus 2, and so on, all the way down to 1. But I'm there now. So n times n minus 1 factorial over n minus 1 factorial. So those now are gone. It's kind of a two-stepper. That's a tough one. So you get 1 over m. Okay? A and B shouldn't be that bad. F's not that bad. Give those a shot.